Hi everyone. So in this video, we're going to learn the charge ICP configuration. So basically, all computer charge ICs have the same working principle. That's why if you understand just one charge IC pin configuration, you can understand any other charge IC. So let's get started. So basically, we have here this charge IC with reference designator of BQ24703. Okay, so here we have U4. Its reference in the motherboard is U4. So let's check it out. So as you can see here in the motherboards, let's check. We have here U4, as you can see, the same reference as we have seen in the schematic. Okay, as you can see, this is the power management IC or the charge IC for this motherboard. So basically this IC is the responsible for the power in the motherboard. So here let's check this pin configuration. So the first two pins, as you can see, we have here AC N and ACP. N basically is negative and positive. So these two pins are connected to this resistor, basically Kevin sense resistor or the current sense resistor. So this resistor has as a purpose the current sensing. Okay, so that's why always it should be connected to two pins in every power management IC. Okay, so its reference is R55. So the second signal or pin we have AC detect. Basically AC detect means when the adapter is plugged to the motherboard or to the laptop, the IC power management detects this adapter. Okay. When it detects the adapter, the battery will stop powering the motherboard. Okay. And when the AC detect or the power management IC detects that the adapter is removed, let the battery to power the laptop. Okay, so AC detect is a very important signal. So next we have enable. So this is just an enable signal, and we have other signals here like ECC. Basically, I will explain to you the main or the important signal. So the alarm signal basically is a very sensitive signal. When there is a problem in the motherboard, for example, something become very hot, an IC or anything in the motherboard become very hot, this alarm signal will be activated, and then this IC will stop powering the motherboard in order to protect other circuits in the motherboard. So here we have IBAT. Okay, so basically this IC is not connected. Here we have the VREF or the voltage reference. Basically for every IC it has a reference voltage. So based on that voltage, the IC know the output voltage that it should generate. Okay, so every IC has a voltage, a reference voltage. Here we have comp or compensation, and here we have NC. NC means not connected. So when you find NC or this signal, sense means not connected, okay, or not used. Here basically you have the EC drive. So the EC drive signal is a control signal that is sent, as you can see, to a MOSFET in order to control it. So when the signal is present here in the gate, the MOSFET will let the power to pass to other side and then generate the VBAT or the main voltage. Okay, so the AC drive is a control signal. Okay. So here we have the VCC, as you can see. The VCC means the working power for the power management IC. So every IC should get a working voltage in order to put in work. Okay, so the VCC. And then we have the power management. This is basically a control signals. Here we have SRP and SRA negative. These two signals are connected to this resistor. Basically, this is another current sense resistor. Always it needs two terminals, so this is a current sensing. Okay, so we find this resistor in the beginning of every circuit and in the end or in the output every circuit. So let's check it out. The motherboard, here we have R45. As you can see here, we have R45, as you can see. So this is a current sense resistor, as you can see, R45 in the output of the circuit. Okay, we have, as you can see, R45, the current sense resistor. So with the next signal we have here the bat drive or the battery drive. Basically here is not connected. Here we have the VS. Basically this should be connected to the ground. The VSS or VS, S means ground. Okay, it's connected to the ground, as you can see. We have other signals like VH, ESP, BAT, set, and BAT, dip. We have the ground, of course. We have this NC. NC means not connected or not used, as you can see. And here we have the thermal. Basically this, because we have alarm, we discard here the thermal. The thermal are discarded here, okay?